Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong and Splunk. My name is Cody J. Brown, and I'll be moderating today's session. We have an exciting presentation ahead, but before we begin, I have just a few housekeeping notes. First, today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you throughout today's program, so please feel free to send in your question at any time throughout by using the Q&A feature. We'll try to address as many questions as you can send in, so be sure to get them in early. I'll also direct your attention to the chat tab. Here's where you can let us know your thoughts, say a quick hello, or tell us where you're tuning in from. And I'll also point your attention to the resources in the handouts panel. Splunk has prepared some materials to complement our live session today. And finally, at the end of today's webinar, we have a drawing for 4 $25 Amazon gift cards. Stick around to see if you're one of our 4 lucky winners. Now, let's go ahead and kick off our webinar. The topic today is Getting Started with OpenTelemetry Observability Best Practices. And I'm joined today by Morgan McLean, Director of Product Management at Splunk, and Steve Flanders, Director of Engineering at Splunk. At this point in time, it's my pleasure to turn the floor over to Morgan McLean to get us started. Thank you so much for being here with us today.
You're welcome, and thanks for having me. So as it was mentioned, my name is Morgan McLean. I'm a Director of Product Management at Splunk. Specifically, I work on all of the cross-cutting functionality of Splunk Observability Cloud. I'm also one of the co-founders of OpenTelemetry, which is what we're here to talk about today. You haven't caught me in my usual location. I'm actually away visiting family right now, but I was able to join the webinar. Just apologies in advance. I'll probably be looking up and down to look at the slides in the back of the camera, but doing that just because I'm visiting family. We also have Steve. So Steve, do you want to introduce yourself?
Sure, yeah. So Steve Flanders, I'm a Director of Engineering here at Splunk. I work on what we call Observability GDI, or Getting Data In. This is everything from instrumentation data collection to third-party integrations and SaaS ingestion. A big focus of the team that I work with is working on OpenTelemetry itself. So we have a lot of active contributors to the project. I came into Splunk about 2 years ago as part of the Omnition acquisition. I've been in the monitoring and observability space for over a decade and have been part of both the Open Census and OpenTelemetry projects since the very beginning.
All right. So first we'll go through the agenda, and then I'll introduce a poll question for everybody before we get really into things. So we're going to start by describing what OpenTelemetry is, what the project contains, its structure, and how you can sort of the capabilities of it. We'll discuss the benefits of using OpenTelemetry over other types of instrumentation. We'll also discuss a bit how to use it with various vendor solutions, including Splunk Observability Cloud. To be clear, Steve and I work at Splunk. This is a sponsored session, so we like to talk about it. But the main thrust of this session is really to talk about OpenTelemetry, the open source project that Steve and I and so many others volunteer on and work on so diligently. And then Steve is going to wrap up with a demo of how to get started. So to begin, we have a poll question that queries everybody about their familiarity of OpenTelemetry. So I'm going to press start polling, and hopefully this appears to presenters. I'm not familiar with the platform. And we'll leave this running for about a minute so that people can enter their answers here. And I see some answers coming in, so I know that it's working. All right, give it another probably 30 seconds. It's funny, when I present at home, I have a soundboard I can use to play sound effects, so I can play the Jeopardy music now. But unfortunately, I didn't bring with me on my trip. Okay, I think we will call that there. So I'll close the poll now. And I don't know if I can present the results to everybody, but I'll describe them right now. So the poll question was, how familiar are you with OpenTelemetry? The first answer had 6% of the population selected. It said, I've never heard of this. The second answer was, I've heard of it, but don't really know what it is or what it contains. That was 6% of respondents chose that. The next was I'm familiar with it and its components, but I haven't used it yet in production. And so that had roughly 31% of respondents. Next was my organization uses it for a small set of our services and infrastructure. Nobody chose that. And then finally, we had my organization uses it widely. And so 6%, same percentage as those who said I'd never heard of it, chose that. Cool. So let's proceed with the presentation, then we'll get into the demo. But thank you for responding to the poll. It's really useful, I think, for us and other viewers. So to begin, I'd like to set the stage with by discussing the sort of state of things in so many organizations today. So in so many ways, there's never been a better time to go build your own cloud services, right? If you want to wind the clock back, say 10 years ago or 20 years ago, to become a company that hosted something like cloud email or a news website or anything of sufficient scale, you effectively had to become a small data center company. This was extremely challenging and complicated and expensive. So it meant that building large, high-scale cloud services was particularly difficult and somewhat uncommon outside of the biggest companies in the world. So now that we have this sort of automated, somewhat commoditized cloud infrastructure, if you want to start a business, if you want to grow your existing business to build large, high-scale cloud services, it's very, very easy, right? You can go to Amazon, you can go to Google, you can go to Microsoft and various other firms and effectively rent cloud infrastructure from them and build your services and solutions on top of that. However, this does come with some challenges. Through this transition, a lot of firms have built out, let's call it a mess of services that respond to each other and interact with each other in order to satisfy your customers' requests and things that come in. And so this can become extremely unwieldy. I'm not saying this is necessarily bad overall. Listen, like it's great that companies have been able to grow and scale up their services on the cloud, but there is a certain level of disorganization that has come with that. And there's a lot of challenges that come with that level of disorganization. It is difficult and slow to develop new software, to extend your existing services. It is challenging to understand how you can respond to requirements to grow your scale. Re-architecting becomes incredibly expensive. And so in this example here, we show, this sort of mess of services that's running on AWS. There's some running on premises. You've got some running on other clouds. You connect to like 5 or 10 or even more different SaaS services that you subscribe to that are all themselves interconnected to your various services. And then your client applications, your mobile apps, websites, desktop applications, etc., have to then communicate with this sort of mass of services running all over the place. As I mentioned before, this can make development extremely slow, so it slows down your development velocity. And it can just introduce so many other challenges to your organization. And the worst part of all is if you work in a sufficiently large or manage a sufficiently large deployment, there's typically no one person or no group of people who have deep insight or really understand what it is you've built. You may have experts who have local knowledge, who understand, in this example, maybe a set of your AWS services and how those interact with a few of your SaaS services, but have no idea how this relates to any of your on-prem infrastructure or anything running there or things running in other clouds. And so you need a solution. You need to have this ability to observe, to understand, to interact with everything that you've deployed so that you can see what you've actually built and how it works in order to be successful, right? If you want to develop software quickly, if you want to build software that's highly reliable, if you want to have a business that functions really well, you need to have observability into this system. And this is where OpenTelemetry comes in. And so there's a number of different signals when we think of observability, which is the ability to really understand what you've built and what you've deployed and how these different components interact and their state and status. There's a number of different signals that you use to achieve this. One that people are probably the most familiar with is system metrics. So think of CPU consumption on every host, memory consumption on every host, those sort of basic infrastructure metrics that probably everyone listening to this has been capturing throughout their entire careers. Next is logs, both from infrastructure and applications. Again, pretty straightforward, something we've been capturing for several decades in high-scale web services. On top of this, you'd also have distributed traces. These are newer, but relatively well understood. And for those who aren't familiar with them, this is the ability to view an end-to-end transaction across all of your services. So if you have an e-commerce system, a customer clicks checkout or something like that, and that goes to your front-end edge service, and then to say like a checkout service or a catalog service or what have you, a distributed trace would show you for that exact chain of transactions from that customer who clicked checkout exactly how that hopped across your services. These are typically represented as a waterfall sort of a waterfall graph, waterfall chart. There are other types of telemetry as well. So profiles, whether they're from a single service or distributed, there's network telemetry and others. We're not going to focus on those as much today, partially just because they're not yet really fully baked or even present inside of OpenTelemetry, and also because they're not used quite as widely as the first 4 types of signals. When we think of these signals, I like to think of them as puzzle pieces. And if we think of observability, the ability to view your system, if we think of this visually, we can think of it like an image that is composed of puzzle pieces. And so we can use puzzle pieces like traces and system metrics and logs and application metrics and custom metrics to fill in this puzzle and provide us true visibility into the system. So OpenTelemetry is composed of a number of different components. I'll describe some in a minute. Steve will also describe some others. Probably the best place to start if we're thinking of the components that developers, that end users actually interact with, is the SDKs and the collector. Generally, you will deploy sort of 2 sets of components to your services if you want to capture data from them. And before I dive into these, I just want to clarify one thing. OpenTelemetry is a project that provides these pieces of the puzzle I described earlier. OpenTelemetry is a mechanism that allows you to capture metrics and traces and logs and other things from your applications and from your infrastructure. You will then process that data somewhere else. That might be Splunk Observability Cloud. It might be a number of other solutions. It might be open source solutions like Prometheus and Jaeger. Really, the point of the project is to send this data, to capture this data, and then send it anywhere else for processing. So back to the artifacts that are actually deployed. So the most common ones that you'll use are the OpenTelemetry Collector. This is an agent that can run as a network service or commonly on each host. It captures host metrics we're in the process of adding logging functionality, so it captures host logs as well. And the collector will pull in this data from those sources, as well as other sources like it has receivers for various like prepackaged applications like databases or message queues or what have you. And it can also pull in any telemetry from any other OpenTelemetry sources, which we'll get into in a minute. The collector then can, if you like, perform some amount of processing on this data and then export it to your backend destination of choice. So this gets you all of your infrastructure data. It also gets you all of your application logs, typically. Next, in order to capture application metrics and distributed traces, you'll either use or use some combination of the OpenTelemetry SDKs, which are language specific. There's one for every popular language, or an automatic instrumentation component. These are effectively alternatives or complements to the SDKs that are language specific agents. And so these will capture distributed traces from your applications as well as any application metrics. Steve, do you want to describe the other components that are included in OpenTelemetry?
Yeah. So, I mean, the best way to think about this project is it's an open source and vendor agnostic way to instrument, generate, and emit telemetry data that you need to actually get observability into your system. Where it actually draws the line today is that it doesn't actually provide a backend, so a destination for where this data is going. Instead, it provides all the plumbing necessary to ensure that you can actually collect this information. And because it is open source and vendor agnostic, it offers an extensible framework for which you can add your own different ways of actually collecting this data, as well as where the destinations, where you actually send this data. So it supports all the common open source solutions that you would expect. So as Morgan was mentioning, from a distributed tracing perspective, you have projects like Jaeger and Zipkin. So you can definitely send to those destinations. You can also receive data in that format. It supports the same thing for Prometheus, and from a metrics perspective, and even logging, there's support for things like FluentD and FluentBit today. So if you're familiar with kind of the open source landscape, especially in more the cloud native world, OpenTelemetry provides a mechanism to plug into that. It also supports a variety of different commercial backends to send that data, like Splunk Observability Cloud, for example, so that this way you kind of have flexibility and choice as to where to send your data. And the idea is kind of an open standard way to actually collect this in your environment, like a one single unified way to do it. So if you're trying to like visualize like where is it and how it's deployed, it's basically everything in your environment, both in your application as well as like an agent. The collector is basically like an agent that runs in your environment to collect this data. And then through configuration, which we'll kind of demo here a little bit later, you can actually specify how to handle the collection, the processing of that data, and more importantly, how you want to like filter and send it, like which destinations, whether it's one, multiple, or some combination. Now, as Morgan was kind of listing earlier, you have the different signals. So that's like the telemetry sources that you're trying to collect from. Traces, metrics, and logs are the most common. There's kind of some nuance to this, as Morgan was kind of highlighting earlier with your metrics. You have both like application metrics and kind of the custom metrics, or like the host metrics and the custom metrics. From a logging perspective, you have like unstructured logs and structured logs. You may even have things like events, which is just a different type of log today in OpenTelemetry. And in the future, there'll probably be more signals that are provided. But for each of the major components here, they're all signals aware. So if we're going to use like an OpenTelemetry SDK, these are kind of language-specific ways to instrument your app. So every major language, Java, .NET, JavaScript, Go, all of these languages are like supported out of the box. It provides a single way for these different signals to actually collect the data and send it back out. And the collector acts kind of as this single binary that you can then use in order to aggregate this information and process it in a variety of different ways. Now, we'll show a little bit of the instrumentation, both like manual, you want to go ahead and modify your code to actually generate this data, or even automatic, sometimes called bytecode manipulation, where through runtime parameter changes and different binaries, that dependencies that you take on, you're actually able to automatically instrument an app without changing the code itself. And we'll see some of the specifics of this in just a little bit.
All right, and we should talk about some of this in practice. So we've got a few examples here. So we just described the components, and in this sample scenario where we have an Ubuntu Linux virtual machine running in, I don't know, AWS EC2 or really anywhere else, and inside of this Ubuntu VM, we're running two applications that we care about. The first is MySQL, right? So this is the standard open source MySQL database. And the second is a custom Java application that we've written that's running on an instance of the JVM. And we want to capture as much data as we can out of this, so we can then send that data out to Splunk Observability Cloud, or really any destination for processing. And so we'll start with the OpenTelemetry Collector, which we described earlier. So we're going to deploy this onto the host as an agent. It's going to capture the core host metrics and logs from the Ubuntu virtual machine. And it's also going to capture metrics from our two applications. So it has a built-in receiver that supports MySQL, that captures sort of core MySQL metrics that you would expect when you're monitoring a MySQL database. It captures those and sends those on to, in this example, Splunk Observability Cloud. Similarly, it also captures some set of metrics from the Java virtual machine about its own performance and runtime, and it sends those as well to our destination of choice. Next, we need to actually get data out of our custom Java application. And so in this case, we've chosen to use the OpenTelemetry Java SDK. So we link this SDK to our application, we instantiate it. We also bring in some instrumentation. So these are packages that you can bring in with the SDK that are specific to the technologies that you're using. In this case, we would want instrumentation for gRPC, because we're using that to communicate with our other services, as well as for JDBC, which is how we communicate with the database. By doing that, OpenTelemetry, the Java SDK, will automatically be able to correlate incoming requests and generate any required spans for those to complete our distributed traces, and also capture out-of-the-box application metrics about the latency and throughput of various requests for gRPC, as well as any relevant metrics that have been built in with the instrumentation for our database requests via the JDBC instrumentation. The Java SDK will then correlate, or rather, it has all of this information that it's capturing. It will send that to the OpenTelemetry Collector, which will then in turn forward that data to our destination of choice. In theory, we could be doing some processing on that data within the collector, but in this example, we're not doing anything like that. It's simply packaging up all the data and sending it on to our destination. And we mentioned there were two ways to instrument a lot of applications before. So as an alternative, we could also use the OTel Java agent. So this is an agent. It is separate from the collector. It is specific to Java. And so it interacts with the JVM and does as a Java agent. And so it is able to perform many of the functions of the OpenTelemetry Java SDK in terms of capturing data from gRPC and from JDBC and completing our traces and capturing relevant metrics. And it can then send this data to the collector. As Steve mentioned, these automatic agents that are available for a few languages are very easy to use in the sense that you don't have to make any code changes to use them, which is great, especially if you have applications that you're not really excited about rebuilding and redeploying, or ones where no one is very familiar with the source code, but they still run. The Java agent is a great way to go and instrument those. There are certainly some downsides. Probably the most prominent is that if you have any custom metrics, right, metrics or custom manipulation of spans or other metadata that you want to be attached to the telemetry that's captured, you can't do that with the agent because you have no way to interact with it in code. In that case, you should use the SDK. Conveniently, you can also use them together. And so they play nicely together, and the agent will automatically send that data onto your destination of choice, which in this case is the collector, which then sends the data to Splunk Observability Cloud or any other backend that you selected. So there's a number of advantages to using OpenTelemetry. Before I dive into these, it's probably best to compare OpenTelemetry to what has existed in the past. So I think actually when Steve introduced himself, he mentioned OpenCensus. There was also a project called OpenTracing. These were two attempts in the open source space to build open source standards and open source solutions for telemetry collection. But probably the better comparison is against a host of different proprietary agents that various vendors, including Splunk, have created in the past. And so there's a number of advantages of using OpenTelemetry over these proprietary agents or over capturing this data completely on your own. So an alternative that some organizations have followed in the past. Both have their challenges, and I'll describe sort of the differences here. So OpenTelemetry, one of the major advantages is that it just has a huge number of integrations with popular languages, web frameworks, application frameworks, sort of everything else. All of these different components of your services that you want to get data and telemetry from, OpenTelemetry has just a huge host of integrations with these, as well as just generally very good language support for language integrations. OpenTelemetry also has very good end-to-end coverage for client applications, for everything from client applications. So like there's OpenTelemetry JS, which you can run on web browsers to capture data from those, all the way to your backend services, to the core infrastructure that they're hosted on. All of these follow the same protocol and the same semantic conventions. This is beneficial because it means that your developers who are actually managing and maintaining these applications and services can use the same set of paradigms and semantic conventions when they operate and generate data. It also means that whatever backend solution you use for processing this data, like we work on Splunk Observability Cloud, there are many others, can also rely on that same consistent set of semantic conventions. So you can do things like trace requests all the way from a client application all the way back to your backend services, and also reference the infrastructure that they're running on. And you can analyze that in a single solution. This is incredibly powerful. OpenTelemetry is also incredibly flexible. We described a number of the different components available. They're all pluggable. You can sort of compose them into different telemetry generation solutions as you see fit. And so if you have a development team who wants to get more involved in this or wants to generate types of custom data, OpenTelemetry is an excellent solution for this. Similarly, if you want to send this data to different destinations, you can do that. And so for example, if you wanted to have different teams using different observability systems, you can do that. And OpenTelemetry supports sending the same set of telemetry to multiple destinations at the same time. If you want to migrate between different observability backend solutions, you can do that. And probably more commonly, if you're using a observability backend solution like Splunk Observability Cloud, but you have some like very specific business analytics or some sort of like heavy processing jobs that you want to run on your telemetry as well, you can use OpenTelemetry to send the data to your observability solution, but also archive it or save it somewhere if you're going to do offline analysis of it. And so that flexibility is incredibly powerful and it's incredibly easy to use. Finally, OpenTelemetry performs very well. As I mentioned, you can move between different backend systems. You can try other ones out. You can use multiple at the same time. And because it's open source, and because if you choose, you can run your own builds, OpenTelemetry is batteries included in the sense that the SDKs, the collector agent, these are, a build of these will just go and run on your own hardware. You don't need to do a whole lot of compositing to make these work or fill in sort of gaps yourself. Because it's so fully featured, if you want to run your own builds because you want to validate your own software supply chain, make sure that there's no vulnerabilities or any sort of malicious code being added there, you can use OpenTelemetry and do that. This is probably this year, I think, has become probably more of a thing, more of a risk that a lot of organizations have become aware of. And because OpenTelemetry's battery is included in 100% open source, you can mitigate this risk very effectively by auditing the source code and performing your own builds. So it's worth talking about the status of the project. We've achieved a number of milestones recently. So the first is the distributed tracing sort of pipeline within OpenTelemetry through all of its components has been GA for some time now. It's being used heavily in production, and we're really happy with it. Metrics has entered feature freeze, and we're expecting Metrics to reach GA extremely soon. So the specification is feature frozen. We already have implementations of OpenTelemetry's metrics functionality that are approaching GA quality in various languages within the SDKs and within the collector itself. And so the metrics GA is really something that we're right on the bubble of. And so that's another sort of major milestone for the project that we're really excited about. It's definitely something that you can go use right now. There are large organizations already using this in production every day. And finally, logs. Next year, we expect to reach beta and possibly GA. And so that'll give us our 3 golden signals within OpenTelemetry of traces, then metrics, and then logs. You can certainly use the functionality of OpenTelemetry logs. Indeed, we at Splunk are recommending it to customers. But there may be just changes in some of the semantic conventions or some small changes in the behavior as it goes through beta and then GA. And so generally, if you're going to deploy to OpenTelemetry, there's sort of a few generally common steps that you can take. So if you're deploying an observability solution like Splunk Observability Cloud of OpenTelemetry, you would generally start by connecting your observability solution to your cloud environment. This is so that your solution, so for this example, use Splunk Observability Cloud, can capture the required metrics or your cloud provider metrics that are actually would come from something like AWS CloudWatch or Azure Monitor or Google Cloud Ops. These are metrics and logs and other data that you can't capture with OpenTelemetry because they're generated by your cloud provider themselves. And so you need to pipe those in and funnel those into your observability solution somehow. This also provides the required resource metadata. Next is that you need to deploy the collector. You would typically, as I mentioned before, do this for every host or for every Kubernetes cluster to capture any relevant infrastructure metrics, any relevant logs from those compute resources, and also to receive any OpenTelemetry signals or signals from other software that the collector is compatible with. And so they can then send that to Observability Cloud for processing. Finally, you would instrument your applications themselves. And so this requires either using the SDKs or using the automatic instrumentation agents that we described before. Those will generally be configured to send data to the collector, which would then send data to your backend solution of choice. You can technically configure these language-specific components to export data directly to a backend, but generally it's recommended to pipe everything through a collector if it's already running on the host. And so before we get into the demo, there's a few other notes I have about how to get started with OpenTelemetry. So if you look around, you'll find there's a number of different distributions of OpenTelemetry. We at Splunk have our own. There's also the core open source distribution, and there's various others. I think Amazon has one that's particularly popular. Generally, I can't speak of absolutes, but generally these distributions are effectively just copies of the core open source distribution. As I mentioned so many times before, the core open source distribution is batteries included. It just works out of the box. And so really, for either the collector or the SDKs, you take that distribution, you include any required instrumentation for the solutions that you want to capture data from, and things will just work. These other distributions generally just exist because of support guarantees. So for example, if you're a Splunk customer, if you want to be able to pick up the phone and call support because something doesn't work with your instrumentation, then you would want to use the Splunk distribution. We have it at Splunk mostly just so that we can make quick hot fixes without having to pipe those back through the open source project. Then we can backport them later when we're in less of a rush. There are other things that we include and some other vendors include just to make things work out of the box. So I talked about including instrumentation. The Splunk distributions include a lot of that instrumentation just pre-baked. So just so that you don't have to reference it yourself. And finally, the Splunk distribution currently relies on FluentD for logging. Just because OpenTelemetry logging is still in development, we're in the midst of shifting that over to using the native OTel logging. At that point, then we wouldn't be as reliant on FluentD. But in the meantime, we include other components just to fill that gap. To be clear, at Splunk, our goal is for our own distribution to always be as close to the open source one as possible. I think that goal is generally shared by a number of other vendors as well. And similarly, for example, Amazon has their own distribution. It ensures that out of the box, you have the right receivers for Amazon metadata and various Amazon services. Again, these are just integrations that you could include yourself in the core OSS distribution, and theirs has a number of exporters included, including one that sends data to Splunk. So if you're already a Splunk customer, depending on the Splunk products that you use, there's different ways you should approach OpenTelemetry. So if you use Splunk Observability Cloud or you're interested in Splunk Observability Cloud, it works natively with OpenTelemetry. The OpenTelemetry is the main set of agents and SDKs that we recommend to customers and that we support. And indeed, we even support OpenTelemetry's native semantic conventions and data models just natively within our product. And so you can use our own distribution or the open source distribution and get started right away. Similarly, if you use Splunk Enterprise or Splunk Enterprise Cloud, granted, these are generally solutions that are more focused on logging, you can capture data with OpenTelemetry, with the collector, and send data, export data to Splunk Enterprise or Enterprise Cloud via the HEC exporter. Obviously, this is less smooth than using Splunk Enterprise and Enterprise Cloud's existing universal forwarder and various other forwarder agents. But if you choose to use OpenTelemetry with that solution, you can absolutely do so through the HEC exporter. Okay, so we've talked a lot about OpenTelemetry, how to get started with it, some best practices. So now I'm going to turn things over to Steve, who's going to walk through a demo.
Awesome. Thanks so much. Before I do, I noticed that there was a large number of people from the poll that were mentioning that they're a little bit newer to the OpenTelemetry concept as a whole. So one thing I kind of want to reinforce, OpenTelemetry is an open source and vendor agnostic project. So it's part of the CNCF, or Cloud Native Compute Foundation, which is part of the Linux Foundation. So it's independently operated. Now, while Splunk does actively contribute to the project, it's one of many companies and many individuals that are active in OpenTelemetry as a whole as well. Actually, what's really interesting about the project is that it really has broad industrial support. What do I mean by that? All three major cloud providers, AWS, Google, and Azure, are actively involved in the project. Every major monitoring observability vendor you can think of is involved in some way with the project, and even end users. So there's a lot of companies whose core competency, like their core technology that they work on or that they sell, is not observability, but they are still contributing to the OpenTelemetry project and also consuming it for use cases in their environment too. Why? Because I think this broadly speaks to a problem that we are seeing in the industry today. Collecting this data is really hard, or it has been hard to date, and the goal is to make it as easy as possible. In addition, it hasn't really been standardized. So vendor lock-in comes in a lot. Hey, I invested all this time and effort to actually add this instrumentation or add this data collection, and now maybe I want to switch, for example. Doing that is a very heavy lift where you need to remove everything and then redo it with some other solution. OpenTelemetry is really looking to solve these problems. The idea here is that you could instrument and use all the OpenTelemetry components, and then it doesn't matter where you're sending the data or how you're processing it, you now have an open standard. But we also understand that not everyone's coming from a greenfield environment. So the idea here is you can also pick the pieces that you want to leverage. Maybe you just deploy the collector. Maybe you just add the SDK for a single language. Maybe you want to have that single SDK only talk to the collector and your other SDKs talk to other agents. All of this is entirely possible. So depending on your business use cases, this isn't an all or nothing thing. You can choose what actually applies to you. And that's part of the reason why OpenTelemetry chose to be completely vendor agnostic, is because there's an understanding that you may be in different parts of your journeys or may have different use cases or different things that you want to plug in. The other thing I just want to highlight before jumping into the demo is just the Q&A. So feel free to add your Q&A questions in. We're definitely going to be covering those in just a little bit. There was one question asked earlier, so I'll just cover that right off the bat right now around, is there a concept of change? So things like git commits or configuration diffs in your environment. So the way that OpenTelemetry works today is that the SDKs, whether they're a manual or automatic, as well as the agent, can be controlled through configuration. So this could be environmental variables, or as you'll see in a minute, the collector supports YAML configuration. Again, flexibility and choice here, how you want to manage that. So if you want to do this through some sort of like GitOps operation, that's totally possible. If you already have like a remote configuration destination, like you're using, I don't know, Vault for your secrets, or maybe you're using like etcd or Zookeeper to like keep configuration, these can all be plugged in. So like the collector can send to etcd and pull its configuration from it. So it really comes down to how do you want to manage things in your environment. Everyone's business use cases can be a little bit different, but there is flexibility and choice every step of the way here. So you can manage the configuration changes however you see fit. Okay, with that, let's actually move to a demo. So I guess let me just set the context real first before I share my screen. So in the OpenTelemetry world, there actually is a demo environment that is pretty commonly used. It's called the microservices demo. It's an open source project. And basically what it is a commercial like web store. So think of it like any web store you've gone to, like maybe you're using Amazon, for example, very similar concept here. You come in, there's a UI, you have the ability of like looking at different products and like the catalog as a whole. And then you have the ability of performing operations. Like I want to add things to my cart, or I want to check out, I want to enter payment information. I want to enter like my personal information for like shipping or like email communication. So this microservices demo is a distributed microservices environment. And it's polyglot in nature, meaning that the services are written in different languages and then they talk to each other. So this is very like cloud native thinking, where maybe I came from a monolith and I broke off microservices, or I've grown my environment over time and I want to have specialized use cases for how these things are written and the ways that they communicate. And this microservices demo application is useful for kind of demonstrating how you can add both manual and automatic instrumentation, as well as how you can get like data collection in your environment. And so that's really what I want to show off here today. So I'll do this primarily from a terminal window, but you can plug it into any product like Splunk Observability Cloud as well, just to kind of get you a little bit familiar with the concepts of how this works. So with that, let me just go ahead here and share my screen, and let's go ahead and get started. So I have basically cloned the microservices demo repository on my terminal window here. And how it works is there's a source directory that has a bunch of different repositories in it. So every single directory here is a different service. So you can see ad service, email service, front end. And these services are written in different languages. So for example, let's go take a look at the ad service. And you'll notice things like Gradle. So we're looking at a Java application here. And so we can actually expand and go look at what exists. And we can go pull up, for example, the ad service Java. Now, why am I pulling this up? So this is just a very simple example of like how this demo application works, but you'll see things in here like gRPC from a communication perspective, some Apache logging, some common Java libraries. What you won't see imported here is anything OpenTelemetry specific. So this is just a standard Java application that someone wrote, and it performs some very basic operations, like what ports it's exposing and like how it logs things, how it starts up and shuts down. But there's nothing OpenTelemetry specific about this service as it exists today. And why I'm showing you is like, here's just a base, like, hey, you made a service, you're in a brownfield environment. How would you get started with OpenTelemetry? So one option that you have available is that you can use automatic instrumentation. So let's say you're in Kubernetes as an example. So you'll notice that there are Kubernetes files in here. And so there's a YAML file for each of the services. So I'll go back to that ad service, which is written in Java, and open it up real quick. And really the only important part, like if you've seen Kubernetes, it's a lot of YAML. We're just going to focus on a few lines here. So 47 to 56. Basically, what we're doing is we're leveraging environmental variables. So if I want to automatically instrument this Java service with OpenTelemetry, the first step is to add the Java agent jar file. So this is a jar file that is provided that has all the hooks necessary. Now, in this example, I'm using the Splunk distribution of OpenTelemetry Java, but you can replace this with just the stock OpenTelemetry Java auto instrumentation library, and it works exactly the same way. So now we have the building block, basically the dependency to add in the necessary hooks. Next, we need to get the local IP address of the node because we're going to run an agent, which is going to be the OpenTelemetry Collector. And we're going to run that as a daemon set, which in Kubernetes world means that you're running the agent on every single host. And that host may have one or more different applications that are running on it. So just a common way of accessing the local agent. We then will tell the instrumentation, the Java agent, where to export that data. So we're saying, hey, send this to the locally running agent on port 4317. This is the default port for OpenTelemetry. It's using the OpenTelemetry protocol, which is called OTLP, but you can use different protocols here. You could use Zipkin or Jaeger or Prometheus, depending on whether you're doing metrics or traces as well. And the final thing that we're doing is just sending an environmental variable for what is the service name. Because you might actually have one or more different Java applications, and you're going to want to be able to distinguish between them. So this just basically gives it a name. And so what you'll notice here is that all I have changed are runtime parameters. I haven't gone into the Java code. I haven't made any code changes. I haven't recompiled the application. All I'm doing is changing the runtime parameters. And if I were to fire up this Java agent, this Java application right now, it would automatically be instrumented with OpenTelemetry. And what you would see is that spans would automatically be emitted for all of the services that are supported by the OpenTelemetry agent. So very easy to get started, very easy to kind of roll out in your environment and to start seeing value. And it's a pretty low lift here, like re-instrumenting your app or recompiling it. That's a lot of work. Changing like just runtime parameters and setting environmental variables, very easy to get started. So one example, one language of how you could get started with just the automatic instrumentation for, in this case, Java. Now, the second thing that I want to show real quick is let's just take a look at a second service. So maybe I'll go look at the cart service. And this service is a .NET application. So completely different language. As I mentioned, this is a polyglot kind of architecture. And let's go pull up the cart service here so we can just take a look at what it looks like. Go up to the top. And the reason why I'm showing you this one is like similarly, it's using things like gRPC, it's using like typical .NET system built-in dependencies. But this application is actually manually instrumented. So now you're actually seeing OpenTelemetry being pulled into the code. And specifically, this is being instrumented for tracing, for APM. So you'll see things like trace and context propagation. So here's an example of you have a .NET application and a developer came in and actually added instrumentation directly to the code. This gives you a lot of flexibility and choice because you can choose what is instrumented or not instrumented, what type of metadata that you're generating, things like that. So really you get kind of some flexibility here. But it does require changing the code. So you add your dependencies in, and then in the case of .NET, you use something called activity source to actually monitor this information and actually collect it. So we're using the OpenTelemetry.NET activity source. We're setting a context propagation format. So basically the power of distributed tracing comes from the ability to do context and correlation. It does that by keeping track of the context. So as calls are being made, that context is being passed with every single call. One simple way to think about this is for RESTful services, it's basically header propagation. So you pass a header that contains unique information like the trace ID, for example, and you pass that with every single call that you make. And assuming a service actually picks up that header and reads it, you can now pass that context and you can actually stitch together what an end-to-end request looks like in your environment. Now, once we have the basic building blocks of activity source and context propagation, then we can actually go through and start implementing the actual instrumentation within our application. So for example, here you can see an add item function. And so in this function, we're saying, hey, I want to go ahead and actually trace this. So I want to generate span information. So every single time add item is called, I want that to be represented and I want that data to be collected. This particular function here is actually adding metadata. So you can see things like component and gRPC method. You can basically add any metadata that you care about, whatever is actually useful for solving both availability and performance problems in your environments. And then you have whatever code you already have in your application. So like what operation is this add item thing actually doing? And then you can rinse and repeat, basically do this for any function that you have. So empty cart, hey, same thing. Go ahead and add your metadata, or get cart, same thing. And if I don't want to instrument one of these, I don't have to, right? As a developer or as a service owner, I can choose what amount of visibility I want into the code itself. So as you can see here, this is a little bit heavier of a lift in that I need to go into my code and actually add the instrumentation itself, but it also gives me a lot of flexibility. So I can control like how much data I'm collecting and how granular or what metadata is being tagged to it. For distributed tracing, it depends on where you are in your journey. So some people are already instrumenting their applications for distributed tracing, in which case manual instrumentation is great. Others are newer to distributed tracing, and so automatic instrumentation provides the lowest friction to kind of get started. And it's usually used primarily for distributed tracing because most software developers today are adding like logging and metrics capability native into their code. And usually it's a lot less complex to do metrics and logging because you often don't have to deal with these things like context propagation. So like stitching and passing context between your calls, maybe between synchronous and asynchronous, handling things like concurrency. It's a lot harder for tracing than it is for typically metrics and logs today. But just another example of a different language, again, leveraging OpenTelemetry, where you can go in and take your existing code and add in the necessary instrumentation to actually generate data back out. And now I can start this application and start calling it like I normally do, and spans are going to be emitted. The same basic concept would apply to metrics and logs as well. I'm just demoing the distributed tracing aspects here. Okay, so that's a little bit about instrumentation. The other thing I want to show you is data collection, so the collector itself. So the collector is really a single binary that can be deployed in a variety of different form factors. So either as an agent, like a binary that runs with your application, or like a sidecar in like containerized environments, or as I mentioned before, a daemon set if you're in the Kubernetes world and maybe you want to run one per host. All of these are supported. Another deployment method that's common would be like a gateway service or like an aggregator. So usually this is a cluster of collector instances that is deployed in like a data center or a region or a realm or whatever your terminology is. And the clustered form is basically just stateless collectors that are fronted by a load balancer so that you can kind of scale up or out as needed to kind of handle your use cases. So I actually have the Splunk distribution of the OpenTelemetry Collector. Again, you could use just the standard upstream OpenTelemetry Collector. That's perfectly valid here as well. And I am just going to actually start it. So I'm going to start the collector itself. The distribution from Splunk actually comes with a built-in configuration. So you can actually receive, process, and export data automatically. It's actually configured to send that data over to the Splunk Observability Cloud for you out of the box. And I am running this locally on my own laptop here. And what you'll end up seeing is it will start automatically collecting metrics out of the box. So for example, you can see it's grabbing the system CPU load average, and you can see all the data associated with that, including the timestamp, any metadata that's associated with it, and what have you. So I've actually enabled logging out of the box here, so you can actually see the data here locally. A typical deployment, you wouldn't be logging this; you would be sending this to a destination like Splunk Observability Cloud. But I just wanted to kind of show you locally here on the terminal. So one command here, I kind of fired it up and I'm already getting value out of the box. It's starting to monitor my system. It's serving as a destination for like those instrumentation libraries that we showed earlier. All that data can start being fed into the system. Now, what can be a lot more interesting is just understanding how you actually configure and run this collector. So configuration today is done via YAML. And so basically it has a notion of receivers, how you get data in and out of the collector. Exporters, receivers, how you get data in. Exporters is how you get data out. And then processors are what you actually end up doing with that data every step of the way here. So let's go ahead and this, and then I'll show you kind of behind the scenes. I am going to create a sample YAML file here. So what I'll do is I'll build receivers, how you get data in. And for the purposes of demonstration, I'm going to use tracing. So I'll use Zipkin, which is an open source way of actually collecting span information. And then from an exporter's perspective, I'm going to add a logging exporter. And I'm just going to set the log level to debug because I want you to actually see the output. So receiver is how you get data in, exporter is how you get data out. I'm not going to do any processing yet. And then we have to build what's called a pipeline. So pipelines are how to actually process data through the collector. And these are signal specific. So we're dealing with traces here. So I'm going to build a tracing pipeline. I tell it what receivers I want to use. So we're going to say the Zipkin receiver. And then from an exporter's perspective, I'm going to use the logging exporter. It's going to log locally here to my terminal screen. And that's it. So this is a very, very basic example, but through YAML, I'm basically able to construct how I want the collector to behave. Now, the collector is very smart about the components that it supports. So you'll notice, like in the case of Zipkin, I'm not specifying any port here. That's because the Zipkin has a standard port to receive data, 9411. And so out of the box, it's actually going to use 9411. I can override it if I want to use a non-standard port that's perfectly supported. Again, you kind of have flexibility and choice with everything that you're doing. But assuming the standard port is okay, I just need to say, hey, I want a Zipkin receiver. And then I need to define it in a pipeline. The configuration here is really two steps. Step one is what do I want to configure and how do I want it configured? And step two is how do I want to define the pipelines in my system as a whole? And then that's basically it. There's nothing else that I need to do in my system here. And for whatever reason, my OTel Collector instance is continuing to run. So I am just going to kill it here locally so I can do my demo. Great. So now what I'm going to do is I'm going to start this collector up again, but I am going to pass the new YAML file that I sent to it. And now I have a collector that's running. Great. Now, for the purposes of demonstration here at the bottom, I actually have an example payload, which is a JSON blob that has a trace in it. So I am going to just call this up so you can see it a little bit better. So Zipkin supports JSON traces as one of its formats. So this just is going to represent a trace with a single span in it. And this is just synthetic data. So like it's hitting some sort of endpoint. It has a bunch of metadata here in it called tags. And this is basically the payload that I'm going to pass over to the collector instance that I'm running. And what's really nice is if I'm using JSON, I can just curl this data. So I'm going to post it to the collector running on port 9411 here and just paste this JSON file. And it will be sent to the collector, which is running above. Now, the collector above has received that Zipkin payload. It has a logging exporter, and it basically logged what it received. And you'll notice that it has the same like foo.bar thing here, and it has the same tags that we were seeing before. So it's just kind of a visual representation of the payload that the collector received. Now, what's interesting here is you're going to see some unique metadata like SSN, which is social security number, which is also PII or personally identifying information. Hopefully no one is adding this to spams, but I'm just using it for the purposes of demonstration. Or you'll see a user field here, which has an email address, which might be considered sensitive, and maybe I want to kind of do something with it. So again, this is just kind of for purposes of demonstration. What I can end up doing next is going back to my collector configuration, and I can add processors. So maybe I want to play with the metadata, so I'm going to add an attributes processor. And I need to specify a variety of different actions that I want to perform. So maybe the action I want to do is I want to delete the key where the key is called SSM. So if I see that key, I want to drop that data because it's sensitive and I definitely don't want to pass that along. Maybe I want another action where I'm going to say hash the user, so the email address. Maybe I still want to hash that information, but I don't want it to be exposed. And then finally, why don't I go ahead and just insert something. So I will add a key, which is called test, and some value, which is called foobar. And let's see how that works. So now I've just defined a processor and some actions that I want to perform on the data that's being received. The only other thing that I need to do is just define that in my pipeline here. So I'm going to say I want an attributes processor. And then we can just go and run the exact same test one more time. So let's go ahead and run that test YAML file. Let's go ahead and post that payload. And what you'll notice is SSN is no longer listed here. We have dropped that data. The user attribute still exists, but I don't see the email address anymore. It's now a hashed value. And I have a new attribute called test, and they value a foobar. So very easily, I was able to handle and process this data that the collector was receiving. This is just one of many examples of what you could actually do with data that is processing through the collector, but really it provides you kind of flexibility and choice depending on your business use cases. So just a very quick demo there of kind of how to get started with OpenTelemetry, both from an instrumentation perspective as well as a data collection perspective. Of course, the power is then sending this data to a product like Splunk Observability Cloud, where you can visualize it, alert on it, do it like anomaly detection, solve both availability and performance questions, even for things that you didn't know about in advance. So really asking any question of your data and getting true observability with your system. With that, I'll turn it back over to Morgan to kind of wrap us up.
Thanks, Steve. So hopefully everybody got a great demonstration and example of what OpenTelemetry is, and they're able to develop a better understanding of it. If you have any questions, please ask them in the Q&A panel. I think it's probably on the right side of your screen. It's on the right side for the presenters. And we'll be happy to answer it in the few minutes we have remaining. In addition to that, we also have a website that we've created called Pipestorm. It's at pipestorm.splunk.com. It's a fun game that aims to take you through some of the basics in OpenTelemetry, and I think there's some prizes of some sort that you can get if you play. Don't quote me on that. And so there should be a link for that that's being presented to you now. But in the meantime, Steve and I will hang out here for another minute or two to see if any questions come in on the Q&A, and if they do, then we'll answer those live.
All right, so I see one coming in just around how data processing and like exporting happens. So the question is around, hey, can I send the data that you just showed to like 2 destinations at the same time? The answer is yes, right? So I only showed you a single receiver and a single exporter, but nothing precludes you from defining multiple receivers or multiple exporters. And what's really nice about the pipelines, again, I showed you a single tracing pipeline. You can have multiple tracing pipelines. So if you want to like filter and only send a subset of data, like one common use case that we see a lot is, hey, I'm running like Prometheus or Jaeger locally, and I want it to receive a subset of the data, but I also have like a commercial product that I'm using, and I want to send 100% of my data to the other destination. Can I do that? Yeah, the collector allows that flexibility. So you can say only send a subset locally and send 100% to another destination. And all of that can be configured through the YAML that you showed that was just seen there.
And I don't see any new questions coming in, Steve. So you might want to be the person, because I didn't even see the one that you saw come in.
That's
so
the only
if
one
you
I
see
see
more,
currently.
speak up. Okay.
Yeah.
Oh, mine's
right, one more. Can I use OpenTelemetry to standardize the way my developers log entries to log files to make it easier to automate troubleshooting and self-healing? Morgan, you want to capture that one?
Yeah, so you can. Keep in mind, though, I did mention that the log functionality is not yet in beta for OpenTelemetry, but you can use it. There's a number of different functions or use cases that we've aimed to achieve with OpenTelemetry, but one of the sort of core ideas is starting to standardize people on specific log schemas or logging semantic conventions or data models. So expect to see more in this space as we continue to develop it and release. But this is one of the big scenarios that we wanted to tackle. Right, when we met with other vendors or the vendors who participate in OpenTelemetry, and we met with like large users of logging, this was probably the biggest or second biggest use case that they brought up is like, I've got data configured across or logs coming in from like 1,000 different hosts running 1,000 different services, and every single one or very, too many subsets of them generate this data in a non-standard way across my org. You can use OpenTelemetry to try and force some of that standardization, particularly for sort of new log statements that you start to author from within your applications. So effectively, the answer is yes, but stay tuned for more in the logging space from OpenTelemetry because it's not entirely finished yet. Okay, so I think we can probably wrap it up there.
Awesome. So Morgan and Steve, do either of you have some closing remarks you'd like to leave our audience with before we close out?
I think we mostly
call to
covered
action,
it,
right? Please try
Yeah.
OpenTelemetry. It's a completely open community. Like anyone can jump in, like no experience necessary. Go take a look at GitHub. There's good labels for good first issue or help wanted. You can join the community meetings. They're all publicly available on the GitHub repositories. So please feel free to get involved, post questions, submit PRs, like whatever, right? Like anyone can be involved in this community, and we look forward to seeing and hearing from you there.
Yeah. And to reiterate something that Steve said earlier, like I'm sure there are other companies that you've heard come and pitch various open source projects that they effectively just control themselves. OpenTelemetry is not that. It's part of the Cloud Native Computing Foundation. Splunk is one of the largest contributors to it, but we're certainly not the only contributor to it. And it has a full community self-governance sort of committee model. And so please, like, if you have any interest in the space, it's a great place to meet people. It's also a great place to contribute and really give back to the community. The best place to go to get started is probably OpenTelemetry.io. That is the main website for the project. On GitHub, we are also available. If you do like a Google search or web search for OpenTelemetry GitHub, will be the first result. We're super active there, and we communicate extensively on Gitter and during our various weekly community meetings, which you can find links to on GitHub. So thank you very much for attending. We hope we'll see you in the community, and or you'll be using OpenTelemetry in your careers and in your organizations.
Perfect. Well, thank you, Morgan and Steve, for taking the time to be with us, for putting together this presentation and the demo. Quick reminder that today's session was recorded. So if you missed any or all of the session, you will receive an email with a link to access the on-demand. You'll also find the on-demand living on the DevOps website shortly after we wrap up today. Our 4 winners of our $25 Amazon gift card drawing are Sasha G, Marcelo P, Alexander D, and Stein K. So congratulations to the 4 of you. Keep an eye on your inbox to claim that gift card. And if you don't receive an email, just check your spam folder. So Morgan, Steve, thank you for being here with us today. And to our audience, thank you for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everyone.
Thanks.